Yeah, thanks a lot for coming here. This is my third talk over these 2 days, so if I'm a bit, then it's probably because I've been talking too much. I usually do. So thanks a lot for coming to this talk about threads. Um, this is something that's I've been actually doing. I think it's the third time I'm doing this talk. I did it 4 years ago, and I did it something like 8 or 10 years ago when it used to be called Dev Days. And it's something that keeps coming up because Qt-based threading seems to be simple, but there are so many places where you can really shoot yourself in the foot with this, because it seems so seductively simple that you just go ahead and things seems to be working, and suddenly it doesn't, which is usually what happens with threaded code anyway. So in that case, it's not worse or bad or better with Qt, but it does bring some extra things. So let's go into what's happening here. Now, first of all, we have this competition, as was said, and at the end of this talk, we will draw the winner of a small drone. It is small, but size doesn't matter. It's more a question of speed. That's what matters. And it's a fast little thing that you can control with C++, and it's quite a lot of fun. If you want to win this, then give your business card to one of the two people going around with something that looks like it should have dog food in it. And if you don't have a business card, there is a small blank one that you can fill out, and then we'll draw a winner, and hopefully it's one of you here. But if it's someone who's not in the room, then we'll send it to the winner after the show. I see some people here who have been to my two previous ones, which is good because then they know all my jokes. But some of them, as you will see, will be on the bottom of the slide. There is no reason for this. It's just a tradition. Every year I come with these bad pun jokes at the bottom of every single slide. There's a new one. Don't laugh at them because I think they're funny. I love pun jokes. So this is a good example of something that is hilarious if you've actually seen Forrest Gump. If not, then probably not. So I run a company called Viking Software that I own together with my wife, and she's probably the one going to pick the winner later. We started this company about 5.5 years ago and chose Qt because this is what I do. I have been programming Qt-based code since 1997 in March, when one of my friends showed me KDE, which at the time was years ahead of anything else you could find on the Linux desktop. Even though at the time it was basically just the loader that worked, the KDM, it was called, where you could log in, and just a bit of the desktop. It was that early. It was Qt version 0.42. That was the first Qt version I started using. So it's some time ago. And over the years, I have been coding a lot of stuff for different customers of different sizes, some huge companies, some very small ones. And a lot of what I'm going to tell you here today is actually experience code when I see what these customers do with threaded code. Some of it has gotten me saying, wow, this is really cool. For example, I did see a customer who was actually using Qt Concurrent, which is brilliant. That's the right choice, but we'll get to that. And then I saw another one which did things that was most certainly not brilliant. And I could help them with that, of course. Viking Software is here in Europe. We have people all over Europe. The people with the dog food things are some of the Vikings. And if you do have a need for help with your applications, then give us a call. Take one of my business cards or whatever. You're going to find us. Viking Software. Can't be difficult. So let's look at what we're going to do today. First of all, I'd like to try to persuade you not to do threading, because your life is going to be simpler if you don't do threading. But if I can't do that, then we're going to look at, okay, what tools should you actually use when you do threading? And then we come to the most important part of this talk. Which one of the 5 different ways you can do threading in Qt are you going to choose for your project? We're going to go through each of them. First, the simple one, then the thread pool, and then Qt concurrent at the end. And finally, I'll tell you in which situation I think which one is the one to choose. Then we'll have some questions, as usual, and after the questions, we'll draw the drone winner. So you have about 49 and 58 seconds to put your business card in before we draw the winner. So, threading. It's something that sounds like a good idea, right? It's so easy. You have this program, it seems to be running slow, so let's just offload stuff into a thread. That's it. That sounds like a good idea. Yeah, no, wrong. It's not, unless you actually have to do it. There are things that you do need to put in threads. And obviously, if you run stuff on machines today, it does have a lot of cores. This laptop has 4 actual cores and 8 Harbor thread things. So it can do a lot of things simultaneously and simultaneously. If you're on embedded, you usually don't win anything with threads because the embedded processes, those are rarely actually multi-threaded. So it might look like you're doing stuff threaded, but you're not, because it just does context switches, and then you don't win anything. Then you only make things complicated for yourself. So if you're in the embedded world, make sure your hardware actually supports threaded multi-threading. Then, if not, then you're free to leave right now, or stay and learn a bit more. The worst thing about debugging is when it doesn't work. Well, duh. But the problem is that we still today don't have a tool for debugging threaded code. I find that amazing. I mean, multi-threaded code have been here since what, the 50s, the 60s? It's so long, and we still can't do it. Why is that? Because this is hard. It is so hard to figure out what goes wrong when you have this. And you have, you know, the old joke, knock, knock, brakes condition, who's there? It's what can you do? How do you debug that? Well, you can't. You can do, don't do threads. And then there is, of course, the last one there. There is things that we can't even offload to threads. For example, OpenGL code. OpenGL code, usually no. Keep that in one thread. Otherwise, well, you probably need to know more about OpenGL than I do before you start heading down that road. QWidget code, you have to keep that in the main thread, mostly. There are exceptions to that. Sure, you can do QImage stuff and stuff like that in threads, but most of the time, if it's a QWidget-based code, keep it in the main thread, period. No threading. So you can put other stuff in threads. That's okay. So if I failed now to actually just say, okay, this is a bad idea. How about I give you some alternatives then? Do something. What do we want to do if we say, okay, how can we escape this threaded monster? The timer-based slicing is one of my pet peeves when I go to customers. It's a simple little class I have. You give it a long list of stuff that needs to be done. It does, I don't know, 10 of them, emits a timed signal to itself to do the next. So the Qt thing can do whatever it wants in its event loop, and then it comes back into this, does the next 10, and then it just keeps doing that. So we use the Qt event loop to put things in small chunks of work which can run while your application is still fresh and shiny and keeps working like it's not running. It's such a simple little thing, this slicing code, but I've seen almost no one use it, and I don't understand this because it is a good idea. So keep this in mind. If you have a large chunk of work, this slicing is actually one of those ways where you can avoid threading. Q application process events, that's the one that everyone hears about. When you have a big loop that goes over a lot of things and this loop takes a long time, you say, yeah, but just call process events in the middle. There be dragons here. This is, I actually at one point spent 2 full days single stepping in a debugger to find out what the heck was going wrong in an application I had taken over. And eventually, I tracked it down to a place where it said Q application, process events, and just above that one, the best programmer I have ever worked with, and it wasn't myself, had written, it is actually okay to call process events here because, and then something I forgot. He had written that because he was convinced that this was one of the places where it was not dangerous to call process events. And still, it turned out that this was a failure. And I called him and say, I found the problem. And he said, oh, what is it? It's your process events. And he looked at the code. Nah, that can't be. And I explained it to him, and he was like, whoa, that's weird. But it was the case. The problem with process events is that suddenly your code can access all over your application because any event in Qt can happen. Now, this flag here, the exclude user input events, is a good one to start with. It means that you can't get mouse presses and stuff like that. But network requests come in. You get timer events, stuff like that, all over your application. Suddenly code can happen while that tight loop, for loop is running if you call process events in there. Be careful. Someone will come and tell you that's the way to solve a problem if you do this. And you will say, no, no, no. I went to this talk. He said it was dangerous. And you stand your ground because it is dangerous. Separate processes seem like a weird choice to have up here because that actually makes the problem worse, right? Now we just put it in a different application. Does that mean we have less race conditions? No, it certainly does not. We can't even put a mutex in that does stuff between these two things. But they don't interfere with each other. And that's the idea behind this line. And sometimes, and it is very rare, that is actually a solution you can try to just simply switch your, that was not a good solution, apparently. So it is a way you can completely break off your application into two different areas. And then they will run at the same time, if you have a multi-threaded machine. And maybe you can get around the worst effects of threads that way. Possible. Okay, enough of that. You have chosen to do threaded code. I have failed to convince you not to do it. Or you actually have a use case where it does make sense, because obviously those exist. So what do you do when you have this? Don't ever use QMutex directly. Don't use QMutex lock. No, you use QMutex logger, because that is the safe way to do it if something throws an exception while you do it. And you say, I don't use exceptions. Well, that's a religious discussion we can have outside if you want to, but it's not the point. It's something can still throw exceptions. You can call a method in a library somewhere that suddenly starts throwing an exception, and you don't know about it. And suddenly your mutex is locked forever because you just called it directly. Use QMutex logger, QReadWrite logger, all of those things. That's the solution to avoid and be threats safety. That's threat safety. That's the word. Okay. Those are the tools here are standard. I remember I was at university in the 90s and computer science, and I was reading a book written by Tannenbaum probably in 1942 or something like that, because he's ancient. But he did write about exactly these tools. He wrote about semaphores when you talk to printers and stuff like that. So there's not anything new in these. And other thread systems have the same system. So they're good. Just remember to use the RAII classes instead of using them directly. Storage. I don't know how many of you have tried to use the QAtomic something. These are actually quite good. What they do is they allow you to use this value like it wasn't a multi-threaded object. So it just basically takes away the race condition of writing something that's a big chunk. For example, a double, that's a 64-bit word, and on some machines, it takes two cycles to write this one. So if you have something that writes that one exactly when another thread is reading them, obviously you have a race condition. But using these atomic integer-like classes, that's going to save that problem. QThread storage, there is something called standard thread storage. I don't remember. There is one in the standard library as well. That one is actually you see it below. If you have a static int, that's the same between all the different threads. But with the QThread storage, you have an integer per thread that you come into it with, if those threads were instantiated with QThread. So that's something you can use in a few very specific use cases. I personally have never found a real-life reason to use this. So I think it's theoretically cool, but not really that useful. I'm sure there is a couple of use cases where you actually really need this one. So just remember that it's there. That's sort of all I have about this one. So the 5 different ways you can do threads with Qt. That's what this talk really is about. What can you do with them? When does it make sense? What is the good and the bad sides of each of these things? I don't know if you even knew that there were 5 different ways to do threading. And maybe you can consider whether 4 and 5 and maybe even some of 3 is the same, but I don't care. I think these are 5 distinct use cases of how you do threads in Qt. I'm going to go through each of them, and starting with the first one. And I think that this QThread subclassing, which is just, I mean, you make a subclass of QThread, you implement run, and in the run method, things run in a different thread. This is probably the way that 90% of Qt threaded code is done. I don't think, with the exception of the one customer that did Qt Concurrent, that I have ever seen customer code work in a different way. And this is a problem. About 10, 12 years ago, I got into a fight on the Qt mailing list with someone who claimed that you should just never do this. And over the years, someone has been writing, you should never do this. A kitten will die every time you do it, whatever, something like that. No, that's not true. This is a tool you can use for some cases. And in some cases, this is the right tool. The place where I do this is if I have that big for loop that just needs to run for a long time, just do calculation, and then I'm done, then this is one of the ways I can do that. So it's not that it doesn't have value. And I don't accept someone coming to you and say, you're never allowed to do this. You should always use the worker thread pattern that I'll talk about in a minute, because that's just wrong. It is a possibility for you. What you need to be careful with here is something called thread affinity, because each Q object has a thread affinity, means it's connected to the thread it's supposed to be running in. And the problem here is QThread, but I'll actually show this in the next one. So if you create an object and you don't have any threads in the system, the thread affinity is obviously the main thread. And if you just have some threads doing some stuff, and in the main thread you still do this, then the thread affinity of your object is still going to be the main thread. But the problem is when you do this, this Q object, let's just see it. So in the constructor of the QThread subclass, you're running in the main thread. Let's just keep it simple here. We have one thread, that's the main thread. This one creates a QThread object, a my thread here, because that's a Q subclass. And we only have those 2 classes. So every Q object either have the thread affinity of the original main thread or the new one. So which part of this code actually runs in which thread? And that's the problem here, because you have different parts of this object that runs in different threads. And that seems weird once you start looking at it. It looks simple, right? You just subclass override run, you have something running in a different thread. Now you create an object, a Q object, somewhere in this object. Which thread are you going to run in? What thread is this object? What affinity does it have? That depends. Because if you have a slot in here, a slot on this object, and you have something coming into this slot, then that slot is going to run in the main thread, not in the created thread, because the thread affinity of this one is the main thread. So you have a slot there, and you say, oh, I know where this is. This is after run, so I know it's in the other thread. No, it's in the main thread. So if you create an object in there, it's going to have the thread affinity of the main thread. Now, if you create a direct connection from a signal that's in this created thread to that slot, a direct connection. You force it to be a direct connection, not an auto connection, not a Qt connection. Then that slot will run in the created thread. And that sucks, because suddenly you don't know what thread your slot is running in. And that is the problem. That is why there be dragons here. It is difficult to do this once you do this, because the QThread object, the QThread subclass, lives between those two. That's usually the image I'd say. You have the main thread, you have the created thread, and the actual myThread object is here in the middle. So you have both of them coming in here. Some will say, okay, then just move that QThread into the created thread. Was that over here? I think it was. So we just do move to thread this. That's the worst you can possibly do, because now you want the destructor to run in the created thread after the thread is done. The thread is done because you just went out of the run. No, don't ever do move to thread this. That's not good. So, yes, you can use this. Yes, it's allowed to do this. And yes, you can do stuff in run. But don't have slots on this object, the myThread. Don't have signals on this object. And only do calculations in there. That is where you will actually do stuff that does not usually hurt. I hope that makes sense. So, worker threads pattern. The guys who said kitten dies whenever you subclass, they came up with this solution. Same problems, just you have less of a chance to actually hit it. That's what you get here, but you do have the same problems. The idea is simple. It's in that run something in a thread method we have down here. So you have a QThread, worker thread. We just instantiate QThread now. We don't subclass it, we instantiate it. Then we have an object, create an object, and say, move that to this thread. Whenever you have something, run it in that thread. Connect something, usually it's the started on the thread, the signal started, that you connect to the run stuff on the worker object. You can do other signals as well, but it's normal to just do started. And then you just call thread start. What happens here is that everything in my object will run inside that one, except the constructor. And what about the destructor? The destructor will also run in the creating threads, not the created thread, because the created thread is done when the kind of destructor runs. Well, you hope it's done. It is. Now imagine that you do a delete on the thread right down here. Now what happens with your my object? Nothing good. That's the answer. So don't do it. Make sure that these objects actually live on until this is done. Usually, this is coupled with something like delete later, something that calls delete later when the thread is done. But again, remember what thread it's in. Now, the connect here, I haven't really talked about that. You have 3 options when it comes to connect. Normally, you just do the connect as it's here. You say from this to this object, from that signal to this slot. And there is a 5th argument after that one, which is default is automatic connection. So what does that actually mean? It means that if these 2 objects have the same thread affinity, then do a direct connection between these 2. A direct connection means when the slot, or when you do emit, then the signal calls directly into the slot. If it's 2 different threads affinities between these 2 objects that you're connecting, then it will do a Qt connection. So set something on the event loop of the target thread. And then when it gets to it, then it calls it in the target thread. This is a very simple way to pass information between 2 threads. And this is actually, once you see this the first time, if you're doing multi-threaded code, you've done it with non-Qt stuff, moving data between 2 threads is difficult. But this Qt connection, it just works, and everyone's like, ooh, this is so great. And they start using threads all over the place because it's so cool. But that's not a good idea. But it is actually quite cool that we can do the Qt connections. And now you know what actually happens there. When you do this, that it is the thread affinity that it decides if the automatic connection is using a Qt connection or a direct connection. So what happens if you say, yes, but I want a direct connection? So I don't use the default automatic connection argument. I force it to be a direct. Then whatever affinity is irrelevant. The thread that runs the emitting signal, that's calling directly into this one, which means you can call an object method on something that should be in a different thread, but it's not anymore. So be a bit careful about that. Sometimes it makes sense, sometimes it doesn't. But be careful, because sometimes now you can have 2 threads running in different functions on this object at the same time. That sounds dangerous, and yes, it is. So, we can do better than subclassing or worker threads. This is one of the good ones. Now we get to the good guys. The QRunnable is a simple little object. It's not a Q object. It's just a data object. You throw some stuff in there, and you say to QThread pool, do stuff. And you override the run method on the QRunnable. That's how you do stuff. So whatever you want to do, this is small calculations. Maybe you have 100,000 different smaller calculations. Just create 100,000 runnable objects, give them to the thread pool, let stuff happen. You get a signal when they're done. That is easy. And it's very safe. Unless you start doing weird stuff, but usually it's safe. Don't delete the runnables before they're done, for example. That can also create bad things. But this is actually one of the simple ways of doing stuff, and I don't understand why you're not using this. I don't understand why. It's so simple. Subclass QRunnable, implement run. Done. When you don't have the signals and you don't have the slots, yes, you can't move data between them anymore, but you usually don't want that. If you do use this pattern, what you want to do is that you want to use it when all of the calculations are done. That's the pattern that you need to use this one for. So let's have a look at Qt Concurrent. I really like Qt Concurrent, but it's a bit difficult to use. A lot of years ago, I was interviewed by Google. They wanted to hire me for a job in Ireland, and I didn't want to live in Ireland, so I didn't get the job. But they were just pounding on me with exactly the same things that Qt Concurrent does. And why? Because all of the Google engine is built with the things that Qt Concurrent does. All of it. They don't have a single thing that happens in the Google search engine that does not map to these methods that this can do. Does what Google do, does that sound powerful? Yes, it does, and it is. But it is also a bit difficult to figure out, does what I'm doing here, does my current problem actually map to what Qt Concurrent can do? That is difficult, and that's why I was so impressed when I actually saw a customer who did do this, who did do Qt Concurrent stuff, but I really like it. It actually can only do 3 things. No, it can do 2 things. It can do map, and it can do filter. That's all. Then it can do a combination of these. It can do filtered instead of filter, whatever. But it can only do those 2 things. The thing you do is you create a big block of work again, and then you say to Qt Concurrent, here, do stuff, and I'm going to show you how in a minute. And then you set a QFutureWatcher, and you get a result when it's done. That's again the pattern we have here. You don't need to know what happens in all of the calculations while they're running. That's again necessary. But if you can do that, if you just need the result, then just let your application run and have a spinner or whatever, or say calculating in the bottom, and let the user continue to do stuff while this calculation is running. So let's do an example of Qt Concurrent Run. Qt Concurrent Run is my 4th list on the list of things that you can do different ways. So we had the subclass, we had the worker thread, we have the thread pool, now we're at Qt Concurrent Run. I split Qt Concurrent Run away from the MapReduce problem because to me they are 2 different things. They are both inside the Qt Concurrent module, but I do believe they actually are 2 different use cases of threads. So that's why I have them in 2 different parts of my 5 list. So we have something that runs slow. It takes a long time. So create this QFutureWatcher and just connect the watcher finish slot to something that says I'm now done and I can look at the results. That's what you want to do. Then you call Qt Concurrent with this function. And that's it. You don't have anything else. So, is that difficult? Does this seem difficult to do? No, of course not. It's really simple. It's very, very simple. You don't have any signals. You don't have any slots. You have safe and easy things that you just run in whatever thread your machine has available, CPU thread. It's easy. And again, why are you not using this? Have anyone here done this? A few have actually. In real life code and not just testing? A few of them are nodding. Good. That is impressive. But it's also the right thing to do. When you have this, anything you could do with the first idea of subclassing QThread and put that in a run method and just doing stuff, do this instead. It's simpler. You know exactly what thread things are running in, because when you're inside your run method, you know that I am running in a different thread. You're not scared that what construct. No, it's easy. You know exactly what's going on. You're in control. That's the most important part here. So use this. Remember the Qt Concurrent Run. That or thread pool run. It's actually, they're so similar that I don't care which one you choose there. You get the results in slightly different ways, but other than that, they feel very simple and very similar to do. So let's go to the MapReduce thing. This is the fun part where it's difficult. So the idea is you have a list of something, and this is a big list. For the Google example, all the websites in the world. That's a pretty big list, usually. There was one guy who said, is it actually a full tree or a forest? I think it's a forest, but whatever. We have a list of all the websites in the world, and we want to do something with all of them. For that, you need a lot of machines with a lot of processing power. At that Google job interview, they talked about O of N of machines. So that's what they're looking at with these things. I think we can do slightly less with most Qt code than that. Let's just keep it at one machine. But in reality, there's no reason to. But usually, I don't think I've ever seen anything in Qt code that isn't just running on one machine. So what you do is you take this big one, this big list, and now you want to transform the contents of the list because you want to run a function on each of the element of this list and then output something. In this example we have here, you have all the students in a school. You want to create the average of every single student. So you have one list, that's the students. You want to have a new list, that's the averages. So you just map the calculate average over each of them. And this will happen in whatever thread is on your computer will be available. Obviously, the main thread runs in the first one, so that's usually not available. But then I have 7 more here. So I have 7 jobs that can just run over each of these items in the list until you are done. And then you get a future signal, I am finished, and here is all your averages. Again, this is simple, and it's not something that you don't do a lot. There were 10 people saying, I have done this, so maybe you have done this as well. I would be impressed, because it is a good solution to this problem. How many times do we actually do this? I don't know. It's not often. I will tell you, it's not often that I meet a problem that can be done where I can do this. But when I do, I'm like, yes! Because then I get to use this and really impress the client. That's always good. That consultants like that. Impress the clients with something you knew in before we started. That's good. So MapReduce is, now we want to have the average of every school student that we have. So we just calculated the average of each of them. And then we want to just have them averaging all over. So in this example, we have an add function. It adds two different numbers. Wow, that's really good. I am paid big money, as you can see. But the idea is you just run over the full list of stuff, and then you have another function that takes all the calculated averages, and then you add them up each one by one. This happens in one thread. So all the calculations over the list, that happens in different threads. The final mob-up is in one thread. You can actually give it a flag to say this should be done in parallel as well, but I have yet to find a use case where that actually makes sense. And in the end, you just divide that result of this calculation by the number of students. Done. This is something that's really hard to imagine. When can I hit a problem that can be done like this? Google does it, because this is what they do. They just they run over each of the websites. They pick out words from these, and then they reduce them to a chunk of sites that if you search for this word, these are the things you should hit. That's stuff they do. So filter. I said it could do 2 things, map and filter. It can actually reduce as well, but okay. So filter is easy. You have a list. Now you want to remove some of them if they don't fit. So this one, I remove everyone whose first name is not Bo, because I'm Bo, and yeah, whatever. And then at the end, I just calculate this into one big HTML page. I slap in some start of it and some end, and you have a website with all the students named Bo something. This is done all of the massaging is done again in different threads. So this sounds difficult. Imagine you had to do this with QThread subclassing. How would you even do that? Make as many subclass objects as there are students? Does that sound like a good idea? No, it's difficult to, it takes a lot of time to instantiate a thread. So what do? 10 of them is in each thread object? Maybe. I don't know, is that the right one? Now you have to start looking at how much time does it take to start up a thread versus how long does it take to do whatever you do on each of the elements in the list. And you have to come up with the heuristic of how many of these objects should you put in each of your subclass objects. Or you just have one and you run over all of it, and the other two cores on my machine are bored because you have a main thread, you have one that runs over my list here, and the other two are sitting there going, what's my work? With this, you parallelize over all the different cores. And you do it without even considering what is the right way to do it. What takes most time? Does it take time to instantiate the thread, to start the thread, to run each of them? Let Qt do it. This is simple. So how many have done something that uses FilterReduce? 1. Good for you. I personally think that even after this talk, the chances that each of you are gonna go home and write anything that have FilterReduce uses this, I think it's small. Because it's not often we hit a problem that can be done like this way, but it's even more difficult to realize that you can transform your problem into something where you use FilterReduce or MapReduce or something like that. But if you do, this is the goodness that happens for you. This is the payoff. So try finding these things. Okay, enough of that. Now, what should you use of each of them? You should use the last one. Don't do it if you can avoid it. Now, if you cannot avoid it, then use one of these last 3 that I showed you. The thread pool, the Concurrent Run, or the MapReduce or FilterReduce. Those are the nice ones. Unfortunately, they're also only maximum 10% of what even I would write. I usually use the worker thread pattern. If I do it, I am aware of the problems involved in doing this, so I can't escape it. There are a lot of what we do that actually best fit the worker thread problem. I do use subclassing, but very, very rarely. Almost never. And if I see code, I do code reviews from time to time, or I'm in projects where I do merge requests and other people look at my code, or I have to look at their code. And whenever I see multi-threaded, and I have to do a code review on some multi-threaded code, I remember this slide. No, I don't, because I wrote it. But I remember the ideas in this slide and try and see, can I do better? Can I do one of the safe ones instead of the unsafe ones? So that is it, and we actually have 11 minutes for questions. Now, you still have some time to win a drone, so you can still put things in the dog food thingies. First, we're going to start out with QThread-based questions. And if we run out of those, we're going to just give you the option of asking me anything Qt-related. Just shoot, I can handle it. And I can actually say I don't know. It's rare, and I will challenge you to get to it, but it does happen. So, first question.
Yeah, I have a question. I used a Qt concurrent map. I used it for downloading a lot of images. I tried it, but I was limited with the Qt Access Network Manager. It does only like 8 parallel downloads. And do you think this is a good idea? Like you have a list of URLs, and then in the end you get back a list of replies. Is this a case you would say this is good? You can use it for this, or is it because of the limit of the Qt Network Access Manager? It's not good to do it in this way.
Because of that limit, I would probably use QThread pool instead, and set the thread pool max to 8.
Okay.
Because then you know that QThread pool will only instantiate 8 QThreads objects and just call 8 of the runnables at the same time.
Yeah.
So you don't have the problem of what's going to happen if you run out of those. And also, it sounds a bit simpler to just do it with a runnable.
Okay.
Because then with a runnable, you make a subclass of QRunnable, and you put the URL for the image in there, and then you have a Q image. You need a Q image. They're not a pixmap because you're in a different thread. So you have the connection between the two. The connection between this is the image URL, and this is actually the target image. And sometimes you need that, where if you only have the list and you just create a list of images, if you don't need that connection, that's fine. But a lot of the times you will actually like to have that. So that's why I would use QRunnable list instead.
Okay, thanks. Yeah, I did some Scala programming. It's functional, and there is, I found this concept really interesting. And when I found out that Qt is doing stuff like this with the MapReduce in future, I really tried it, and so this is the reason why I used it. Thanks.
That is a very good reason. Not because it's the best, because I can.
Hello, thank you for the presentation. I have one question. If you have a desktop application and you're having a heavy calculation, would you advise against using a QThread running as a worker for calculating the stuff and then using those data in the application again?
It depends. I know that answer sucks. I know it. But it so much depends on what actually happens inside that long calculation. It also depends on, do you need to have some kind of a bar that says how far into the calculation did you go? Do you need to pick up stuff all over the application while this is running? So many different things. If you just have a pure calculation, just a for loop that runs, and then when you're done, you can pretty much use any of these actually, because you don't have a signal that escapes this calculation, this for loop. So a subclass will do. I wouldn't do that, because just throw it in a runnable and give it to the thread pool and let it tell you when it's done, or put it use Qt Concurrent Run and then put a future watcher on it. I would probably do one of those instead. But which one of these exactly I would choose depends probably on what month it is and what my mood is and how much I want to impress with my Qt concurrent skills. I don't know. It's difficult to say. I would say that any of them is probably fine. Yes?
Okay. What would you recommend to run code in the main thread from a random thread?
I'm sorry, could you repeat that?
What would you recommend to run code in the main thread from a random thread?
What would I recommend to run code in the main thread
Yes.
from another thread?
Yes, a random one, so where you don't have any control.
Qt connections between signals and slots. Because if you have a different thread and you need something executed in the main thread, then by far the easiest is to emit a signal. You have a Qt connection. It will arrive in the object that have the thread affinity to the main thread. and then run there. That is by far the easiest way to do that. So to do that, you just lost QThread pool and Qt concurrent, both the run and the MapReduce. So now you're back to subclassing QThread or using one of the worker items. Usually. I mean, sure, inside a Q runnable that you give to the thread pool, you can instantiate an object, which is a Q object, and you can connect that to an object in the main thread. And yes, but that, I mean, you can hear how convoluted that sounds, right? So in that case, I would probably end up using a worker thread pattern there. Next question?
Yeah, would you recommend using OpenMP instead of Qt?
Where are we? There.
Yes. So the
Okay, sorry.
Sorry, the question was, would you recommend using OpenMP instead of Qt concurrent?
I don't care. I don't, whether you use Qt concurrent or OpenMP, I don't care. Both are fine. If I usually say use the right tool for the right job, and if two tools are just as right, then use the tool you know instead of trying to use the tool that's giving to you. So, and you also need to consider the rest of the guys in the team. Do they know OpenMP, or do all of them know Qt concurrent? Stuff like that is what's going to give you the answer. So when I decide on stuff like that, I have one word that I always keep coming back to, and that's maintainability. Because code is going to live for a very long time. There is code in Qt that Erik or Håvard wrote when they were doing their PhD thesis and came up with Qt back in 1991. And it's still there. I have an employee that was working for a company in about 2001, I think. And then he went away, did something else. Now he's working for me. But 4 of my guys are working on that project now. And they did a git blame on the code. And they saw his name in there. And it was like, what? And that was just an engineering company doing their thing. But it's still there. So writing code that you can maintain over the years, that someone who has never even met you, perhaps, will have to take over and maintain, to me, that is a lot more important than whether it runs 10% faster. To me, it's almost irrelevant to run 10% faster. Maintainability is what it is. So when I get a question like that, should I use that or that? I say, which one is the most maintainable? Which one is the easiest for other people to understand? That gives you your answer. Not whether one of them is slightly better. That's not the right answer. It's which one is easier to work with in years to come. And the moment you come back to your own code 5 years later and you don't understand it, that's when you realize that maintainability is really important. It will happen to you if it hasn't happened already. And I can assure you, you feel pretty weird. One more? Yes?
Down here, last question maybe. I'm actually one of the creatures that use Qt Concurrent Run. And what I saw are 2 limitations by design. The first one is you can return only one value. So if you want to return a value or an error condition, you have to create some type of DTO or whatever you want to do. And the second one is you can't interrupt it or report progress from within the function.
Yes.
Do you know any dirty tricks on how to do that? Other than perhaps creating a variadic Qt concurrent run?
Well, yes, because I have done Qt concurrent code where I needed to have the progress bar up. And the only solution I can come up with is a Q-atomic integer that you increase every time you're done with one of the objects in the list. And I don't know of any better way. And obviously the main thread, you just, every time that one changes, you update the progress bar, or you do it every second, or whatever. It doesn't matter at that point. The point is, if you have a shared QAtomic integer with a counter, and you know what the actual amount that you're going to get to is, that's the solution that you need. And I don't know of a better way. It is one of the things people ask about QThread pool run. When is it done? On my list of objects, or how far did my job at filtered or reduced actually get? And I have not found a way either to do any other way than this. And stopping them, don't do that. It sounds annoying, I know, but it's very difficult to do it. And there was one guy who asked me to do it, and I said, is it okay if it just keeps running in the background without the user being able to see it? And he said, yeah, why not? Okay, cool, we've solved the problem. Then just don't report that it's done. This sounds really weird, but it's actually surprising how often that helps you. And if your application is done, just let it kill the threads. It doesn't matter. I mean, as long as you've saved all the work, who cares if it does weird stuff with the threads at the end of those? So that was the last question here. So it's time to draw the winner of our Crazy Fly drone. So Christina, will you do the honors of? Oh, we have more over there. Yes. Any last minute entrance? Nope. It's a good. Just look how fast the Viking can be. So, who do we have? I forgot my glasses. What is this? Menno van der Beek? Is he in the office? No, damn it. We'll mail it to Mr. van der Beek. So, oh, it's you? Yes. Oh, congratulations. Is that you?
Oh no, it sounds likewise, but
damn it. Okay, so we'll mail it. Thank you very much for coming. I hope you all enjoyed Qt World Summit, and we'll see you next time here in Berlin. Thank you.